All right, let's take a look at this one. So if x plus 2y multiplied by dy dx equals 2x minus y, what is the value of the second derivative of y with respect to x at the point 3, 0? So this is just like an implicit differentiation problem, so let's go ahead and write it out. So I want to take the derivative of both sides, and let's see, derivative of the other side. And then the key here is just remember that y is a function of x. So anytime that I derive y with respect to x, I'm going to need to tack on that, that dy dx. Okay, so let's go ahead and run this through. I have a product here between the first derivative of y and then this little expression here. So what I'm going to need to do is use a product rule. So I'm going to have 1 plus 2 dy dx, because I'm going to take the derivative of that, and then I'll multiply it by that other half of it, and then I will need to add that to the derivative of dy dx with respect to x, which is just going to be the second derivative, and then I'll, of course, multiply this by that initial expression. Okay, and then the derivative of the other side for right here, well, that's just going to be 2 minus dy dx. Okay, so pretty straightforward. Now the key here is to recognize that we have an expression for dy dx, so let's just go ahead and plug in that expression. So if I rewrite dy dx and I divide both sides here by x plus 2y, well then what I'm going to have is 2x minus y divided by x plus 2y, and then I can substitute that in anywhere that I see a dy dx. So let's see if there's any easy way for me to simplify anything here. Let's see. It looks like the best move that I have is to just plug everything in. So actually, yeah, I think that's probably as good as we're going to be able to get. So I'll have 1 plus 2, 2x minus y divided by x plus 2y. And again, I'm just substituting in for dy dx here. So then 2x minus y over x plus 2y here. So all this is going to be in parentheses, plus my second derivative here. And then x plus 2y. Then, of course, it's going to equal 2 minus, let's see, 2x minus y over x plus 2y. Okay, so now hopefully this is going to be easy to simplify, but let's see if it actually is. So let me go ahead and clear some space here so that I can write out my final expression. Okay, so now what I'm going to do is just see if whenever I plug in 3 for x and 0 for y, if anything easily cancels out here. So let's see, let's just go ahead and write out 1 plus 2, and then 2 times 3 is going to be 6 minus 0, so I'll just leave out the 0. So I'm going to have 1 plus 2, 6 divided by 3, and then let's see, it's going to be the exact same thing here, 6 divided by 3, plus that second derivative. Oops. Okay. And then x plus 2y, that's just going to be 3 equals 2 minus, and then of course 6 divided by 3. Okay, so now I'm just going to simplify 6 divided by 3 into 2. So I'm going to get 1 plus 4, 2 plus d2y dx squared, 3 minus, I'm sorry, this should be an equal sign. So it's going to be 2 minus 2, which is 0. Let's see, so then I'm going to have 10 plus d2y dx squared times 3 equals 0. So whenever I fully simplify this, I'm going to have d2y, or sorry, I don't know what I'm saying like that. The second derivative of y with respect to x, that is going to be equal to negative 10, and then I'll need to divide both sides by 3. So again, this divided by 3, and this is, of course, negative 10 once I subtract 10 from both sides. So final answer is going to be negative 10 divided by 3, which is going to be answer choice A. So hopefully that makes sense. That is, in fact, the correct answer. If you have any questions, feel free to comment below, and I'll see you guys in that next video.